I and j are unit vectors north and east. A resultant force of 2I minus 3j newtons acts on a particle of mass 2 kilograms. We want to find the acceleration of the particle as a vector and find the magnitude and bearing of the acceleration vector. So we have our object and we have a force that goes 2 newtons this way and 3 newtons that way. And of course, F is equal to ma. So 2 negative 3 is equal to 2a. Dividing both sides by 2 gives me that a is equal to 1 negative 1.5, and that would be in meters per second squared. So we want the magnitude and bearing. So we're going 1 that way and 1.5 this way. And so it will actually accelerate in this direction here. And this is north. So the actual acceleration, the magnitude of the acceleration, just by Pythagoras, is the square root of 1 squared plus 1.5 squared. So square root of 1 add 1.5 squared. So that's going to be 1.80 meters per second squared. It's 2 dp. And we really like this angle just here. So theta is going to be the inverse tangent of 1.5 divided by 1. So shift tan 1.5, I don't know why I did that, divided by 1. Should have just put 1.5 in there. And that's 56.3. And so the bearing, remember, is clockwise from north, so we need to add 90 degrees to that. So the bearing is going to be 146.3 degrees.